This is Mr. Martin. These are video notes for Pre-Calculus Advanced. We're in Unit 7. This corresponds to Section 7.7 in your textbook, and we're talking about solving trig equations. So if you happen to have had given this a try before you started the video, that's great. I'm going to go through the solution so you can check, and if you feel like you want to fast forward to the end, feel free to do that as well. So this one's a little bit different than ones that we've done before. It's a little bit more complex, and we're going to use a different technique or an additional technique to solve this. So we're going to collect all the terms over on the left side. So I'm going to subtract 1/4 cotangent x from both sides. And these are not like terms, so I'm simply going to have cotangent x cosine squared x minus 1/4 cotangent x is equal to 0. So as you do more problems and get more experience, you'll notice certain times it'll be useful to factor. And this is one of those cases because I have two terms here. I have this first term cotangent x cosine squared x, and I have this second term 1/4 cotangent x, and they both have a cotangent x in common, and I'm going to go ahead and factor that out. So cotangent x, when I factor it out of the first term, I'm left with cosine squared x, and when I factor it out of the second term, I'm left with 1/4, and that's going to equal 0. So now I have a product. I have cotan x times cosine squared x minus 1/4 is equal to 0. And if you recall from algebra, if I have two expressions multiplied together and it equals 0, either A has to be 0 or B has to be 0. That's our zero product property. So in this case, I have these two terms that are multiplied together at equals 0. So that means that either cotangent x is going to be 0 or cosine squared x minus 1/4 is going to be 0. So what we end up with are two parts to this. And before I move on to solving these, I want to point out that if at the beginning you divided both sides by cotangent x, you would lose any solutions that you would get from this portion of the equation. So it's very important. Remember from algebra, when you're solving an equation, you never want to divide by a variable or an expression that has a variable in it, because you will lose part of your answers. So we've got these two parts here, and let's start with cotangent x equals 0. So let's take a look at our unit circle. We remember that cotangent of theta is x over y. So in order for the cotangent to be 0, that means that our x has to be 0. So where on our unit circle is the x going to be 0? That's going to be up here at pi over 2. That's 0, 1. And again, we're going around one time because the problem specifies on the interval from 0 to 2 pi. And down here at 3 pi over 2, so that would be 0, negative 1. So these would be our two solutions here. We've got x is equal to pi over 2 and 3 pi over 2. This is for part A. Now over here we have a little bit more to do. I've got that cosine squared x is equal to 1/4. Then I'll take the square root of both sides. I've got the cosine of x is equal to positive or negative square root of 1/4, which is positive or negative square root of 1 over square root of 4, which is just positive or negative 1/2. So this is a little bit different situation for us here. than what we've looked at so far. We want to find all the angles as we go around one time where the cosine is either positive a half or negative a half. We know that all of our pi over 3's have coordinates 1/2 and root 3 over 2. So some of them are going to be positive, some of them are going to be negative, and we want all of them. So I've got pi over 3 here. Okay, my x coordinate is going to be positive 1/2. My next one is 2 pi over 3. My x coordinate would be negative a half. Then I've got another one here. That's 4 pi over 3. And my x coordinate is going to be negative 1/2 there. And my last one here is 5 pi over 3. And my x coordinate there will be positive again. So when I'm finding my specific solutions, I'm going to have all my values of pi over 3 that are between 0 and 2 pi. I've got pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So that's for part A. Now for part B, I need to find my specific solutions. So if you want to go ahead and try and write some specific solutions for these, I would encourage you to try and do that. When we do that, we always want to write the least number of specific solutions as we can. So keeping that in mind, if you'd like to pause the video and see if you can figure those out, feel free to go ahead and do that. Alright, so if you decided to pause the video, you can compare your answers with the ones that I'm going to write here. So for this first one, if you notice, pi over 2 and 3 pi over 2 are equally spaced around the unit circle. They happen to be 180 degrees or pi radians apart. So if I am traveling around the unit circle multiple times, every 180 degrees or every pi radians, I will hit another solution. So if I'm trying to write solutions for this, really all I need to do is go to pi over 2 and then keep adding pi k number of times. So it's a little bit different than the examples that we've done so far. Most of those we were using 2 pi because we were just trying to get back to the same spot. But now we're trying to hit 2 different spots as we travel around the circle. So even though I have 2 solutions as I go around the circle every time, I can bounce back and forth between those spots by adding pi instead of doing 2 pi and having 2 separate solutions like in the previous examples. And if we carry over that same idea here, it's 180 degrees or pi radians again between pi over 3 and 4 pi over 3, and then 180 degrees back there. So even though I have 4 separate solutions here, I don't want 4 separate equations for those solutions, because the idea is to write the least number of solutions as you can. So for these two, which are 180 apart, I can write x is equal to pi over 3 plus pi k, again because they're 180 apart, and my 2 pi over 3 and my 5 pi over 3 are also 180 degrees apart. So I can write a similar equation for those. X is equal to 2 pi over 3 plus pi k. So if you didn't get those and you're not happy with the explanation here, make sure that you ask questions when you see me in class, and we will see you in the next video.